Hello everyone! In this episode, we'll explore how Reliably can help you figure out if you've set up your observability and communication platforms effectively. To achieve this goal, we'll run an experiment which cordons a Kubernetes cluster node while the other nodes of the cluster are already cordoned. Therefore, pods won't be able to be scheduled anymore, existing workloads will keep working, but the cluster won't be able to find any appropriate node to schedule new workloads. So when could this happen in a real-life situation? For example, during maintenance, or during a security breach, or during any incident, and in the heat of the moment, it's sometimes hard to be certain each decision is the right one. Obviously, because this is a demo, the situation is a bit forced, but it could happen. And these situations usually happen under duress. So let's explore this. Our experiment is fairly trivial. We have a simple steady state that looks at whether or not our users were impacted, and we do so by measuring the number of errors during the run of this scenario. Then the first thing we do is start injecting some load into the application itself. We will do this in the background so that it runs during the whole experiment. Then we will cordon the node, and we'll wait a little bit and we'll get some data from our cluster. Then we'll terminate the pod. This will force Kubernetes to reschedule it, and obviously because at that stage all the nodes will have been cordoned, so it won't be able to do so. And finally we'll get more data and we'll wait for the traffic we sent to the application to stop. As a rollback, we'll uncordon the node that we cordoned in the first place. So how do we get there? We'll run the experiment in the Reliably cloud, and we'll use this environment which will provide the required information to connect to the target systems. We'll run this now, and we'll select the Honeycomb and Slack integrations. The Honeycomb integration sets the telemetry endpoint to which we send our traces, and the Slack integration sets the channel our team will look into to go through this incident. This is our plan for the experiment being created, and whilst this is running, let's have a look at how we set up our open traces. We've already done some runs, and here we're using Honeycomb's capacity to ingest open telemetry traces. These traces will let us know when the experiment started and everything that happened whilst the experiment ran. And here in Slack, we can see that our experiment has started as we've received a message telling us so. And if we look into the thread, we can see that it already cordoned the node. And if we open our terminal, we'll see that all the nodes are now cordoned. Now this pod has been terminated and is in pending mode. It cannot be scheduled anymore. And here is Honeycomb sending us an alert, as we've set an alert for the number of errors, and therefore it already knows that something has happened. We're starting to have an interesting view of the experiment running. If we click on this link in the Honeycomb message, it takes us to this graph view where we see a number of our errors spiked. And if we go and have a look at the traces, they're starting to pop up. And what's interesting in Honeycomb here is that we can see traces for our experiment. Some of them are not finished as the experiment is still running. We can also see all the traces for our load injection simulating traffic. So if we go back to Reliably, we see it's running. In the timeline, we have all the information that we need. We see that we've cordoned the node, and we have some information about our pods. Here it says our node couldn't be scheduled, and basically it describes all the nodes. Here is where we terminated the pod. and it shows the label of the pod that was terminated. Here we read consumer logs. The consumer service is a service that talks to the one that we restarted and couldn't be rescheduled again. And so we see that at some point it stopped being able to perform its duty. Obviously our application shouldn't be resilient to that, but we made it fail on purpose for this demo. Here is where we fetch the Slack messages, and we see that we did receive error messages, and we can see them here. Now the experiment is finished, and if we come back here, we can see that we've deviated. We did have an impact, as our steady state was expecting no errors at all. If we look at the results of our action, we actually have 265 errors, which is quite normal as it ties back to the consumer logs. The first requests were healthy, and then we started having failures. So if we go back to Honeycomb and we have a look at the traces, we have 223 traces because we've traced everything. And this activity is the one where we send traffic. And we can see it went from a violet colour to red. And then the red traces happen when we started to see errors. And it happens just after the 20-second mark. If we scroll down the page, this is the one we're interested in. This is the activity that terminated the pod. It happened just after the 20-second mark. We also noticed that some of them towards the end were back to good, and that's when our nodes were back to scheduled, and therefore the pods could be scheduled. Now we see here that the alert has been resolved and we're back to normal. What we have now is a very nice automation to explore how coordinating nodes in a Kubernetes cluster can impact the system when some pods need to be rescheduled, whatever the reason. It shows that while Kubernetes' ability to schedule pods for you is great, it can fail if your nodes are not ready to be scheduled on. This experiment shows you how your system will react in this situation, which alerts you'll get, when you'll get them, and where they'll be sent. It enables you to start devising a better strategy if you didn't have the right policies in place. Thank you for watching.